There are a lot of been enhancement that has been happened in the field of modular run management, and today me and my colleague Sriram will be highlighting some of these functionalities that are available from version 22 and upwards. If you now, by now, you probably will be aware that ANSA offers a unified environment for modular run management for composition of a simulation runs to complete key results management. And obviously, this functionality is completely available for all disciplines now. So in version 22, we have expanded this and improved the infrastructure for the modular run environment aimed at focusing on the following four key aspects. The first one is the workspace, where we will be improving the user experience to make it environment, we make the modular run environment more appealing and user friendly. The second one is the methodology to improve the day-by-day work in the modular run environment. The third one is the collaboration, where users would be allowed to use multiple DM efficiently and also collaborate between different team members on let's say same discipline as well as different discipline as well. And the last one will be showcasing on the configuration side, where we can facilitate the configuration of the modular environment much more efficiently. So I'll be showcasing the first two developments in the workspace and the methodology slide. So let's get started with the workspace of the model run management and the changes that we have introduced in order to improve the user experience and the user friendliness to keep the environment more appealing. So if you have to facilitate and simplify the creation of the intermodular connectors, we have now simplified the GUI for the intermodular connector that connects two subsystems, as shown in the figure here. So the new GUI offers users to have a very simplified manner where user would be able to select the connectivity of the subsystem 1 and the subsystem 2. And on top of that, they would be able to also define certain more things like search distance and other options, and where the position of the connector would be will look like. A connector that we define could be considered as an intermodular connector when it is connecting to two subsystems, either using A points, LC points, or interface states or interface properties. There is also an option to populate the old GUI of the connector using, if you go to the connector list and hold on to the shift mouse, you will still be able to populate the old GUI of the connector if you want to make some changes to that. This functionality is completely in sync with, let's say, the A point connect GUI that we introduced in version 21. So both the GUIs are simplified now in order to facilitate, let's say, a simple creation of either A points as well as the connector entities. Now, in regards with the lifecycle graph and the reference graph, we have identified the model containers that uses the selected DM object. So the lifecycle graph has been enhanced in a particular manner where for a particular subsystems, the user would be able to not only showcase the simulation models that consist of this particular subsystem, but he can also get further reference in a graphical manner for all the simulation runs that has also been referenced by that particular simulation models. In additionally, we have two functionalities now available in the reference graph. So the first one is where used graph and also the entity selected. So when you select a where used graph, users will be able to select a particular simulation model and it will automatically will highlight the simulation runs that are getting affected using that simulation model. So this will allow users to quickly identify if somebody is making a change on a subsystem level. This will allow the user to quickly identify the simulation models that are getting affected, as well as the simulation runs, and he could resubmit all of those. Another option that has been introduced for ease of navigation onto the graph itself, we have introduced a GUI with the utility buttons such as to facilitate the visibility control of the reference graph as well. So users would be able to see the previous and next version of a particular subsystem or simulation model, and you can navigate properly. Additionally, there is a tab called as show the solver representation itself. So users, once this tab is let's say checkbox, users would be able to see the solver representation available for that particular subsystem. One of the major enhancements and let's say one of the major tool that is will be available from version 22 is the results logbook. As you probably will be aware that ANSA DM functionality allows you to have a very comprehensive key results management using ANSA DM and SPDRM as well. Now we have further enhanced this functionality to in order to support let's say in order to support the let's say the creation of the logbook, where users would be able to have a very good tabular manner or a GUI feature where users would be able to use an Excel template consisting of certain formulas and formatting, color coding formatting, so conditional formatting, where users would be able to see this for all the iterations they have performed. The user would be able to capture the complete key result values and show them into a complete logbook manner where conditional formatting can also be automatically applied. This will give a complete overview of the iterations that has been done for a particular program and also the changes that has been made for it. Okay. Finally, on the workspace level, when we are using SPDRM as a backbone to the DM of ANSA, it is a possibility now that you can completely invoke the SPDRM script actions directly from the ANSA DM browser. So you can right click on a simulation run or a simulation model as showcased here, and you could be able to automatically, uh, let's invoke certain SPDRM script actions, which could be, let's say, for example, run a post-processing simulation or submit a job to directly HPC, which will export the particular simulation run in certain manner. A dedicated tab available on the right hand side of this DM browser, where users would be able to, from these three dots, user would be able to select the SPDRM actions, and they can manage these actions as well. Similarly, there is a utilities tab, and also users would be able to add their own script actions at this level as well, which will only be working on the ANSA DM browser level using ANSA scripting interface. Now, moving on to the methodology side, another very important enhancement that was been done to improve the day-to-day life of the users and keeping the user friendliness, or let's say making use of the existing functionality. And a major new feature is the enhancement of the smart assembly process, where users would be able to use the plane connection entities for the intermodular connectivity. What do I mean by plane connection entities is that you can now use the connection lines to connect two subsystems together. And this the connecting subsystem, or let's say the connection line, could also be stored into the DM and version controlled as a connecting subsystems. So when you save a simulation model as shown in this example, where we have a body and a door, which is connected by a let's say a connecting line or a sim line or a SWOT line, that can be stored as a connecting subsystem, and you can also version control them. We have further enhanced let's say the compatibility of these connecting subsystems. So when we store this connecting subsystem into the DM, it automatically stores the intermodular connectivity links between those two. So when you select the connecting subsystem into the DM browser, you would be automatically able to see in the reference tab that this connecting subsystem is connecting the body and the door. And on top of that, you will also see a flag that called as compatible and non-compatible. So in the next couple of slides, I'll be explaining you what is this compatibility means and how ANSA or the smart assembly feature will automatically detect the compatibility of a connecting subsystem. So let's take an example on the same example that we have, where we have a door module and we modify the door module and certain, let's say, material on the hinges and store another version of the subsystem of the door. Similarly, we also modified and remesh certain portions of this door and store another version as a version 3. Now, in addition, when we store all this information, all the time, ANSA is tracking and let's say looking into the compatibility options of the connecting subsystem that is available. So let's say once we store all these two different versions into the DM, users will be automatically will be able to see from the connecting subsystem itself that this connecting subsystem is now referencing to two more versions of the same subsystem, that is module 2, and it also flags that there is a compatible and incompatibility flags. So when we are so what does this compatible and incompatible flags allows us? So when you do a build action on a simulation model level, where you have the module 1 and module 2, and it consists of the connecting subsystem, it automatically shows you that the connecting subsystem is already compatible with the module 1 and the version 2 of the module 2. That's because you have only changed the material and there is no changes on the geometry level. You don't need to load these modules. You don't need to load these modules, and the existing, let's say, the connecting subsystem that you have already stored into the DM is already compatible. So you can reuse it completely. On the other hand, where you have remeshed the door, in that manner, ANSA will automatically will detect that this connecting subsystem is not compatible, and it will ask users to load the door and the body model in order to recreate or re-realize this connection line in order to let's say store. And you can store now another version of this connecting subsystem in order to reuse it in the future. In the similar manner, we have added a set-based smart assembly that was already available in the previous section, previous versions of ANSA. But in this one, we have modified it in such a manner that users could be able to use GBs in order to create, let's say, for example, in this particular example, we are showcasing that you have a plate as a subsystem 1 with an interface set defined with certain elements, and you have defined a GEB which creating a mass, let's say nodes, a distributed mass, and that can be stored as a connecting subsystem into the DM. Once you store this information into the DM, those two information will again be stored as subsystem 1 and the connecting subsystem, which is consist of the GEB for the distributed mass. Now let's create, let's take an example where you modify the base subsystem. For example, you modify certain thicknesses of the baseline subsystem. And the second version or the third version of the subsystem that you're saving is by modifying or remeshing this plate, where the set definition is also getting changed. So ANSA can automatically, when you store both of this information into the DM, ANSA again can automatically trace and track that while you are doing the build action, it can again identify the compatibility of the connecting subsystem, where for the first one, where you have only changed the thickness of the plate, there is no modification to the set level. And on the version number second or the third of the plate, where the plate is remeshed, users would be needed to, let's say, reload, or the connection subsystem needs to be created again and stored as a new connecting subsystem itself, okay, or another version of the connecting subsystem. Another very important aspects of the methodology is the next iteration. So when we have, I'm not sure if you're all aware, but ANSA on the ANSA DM on change set management. So we have introduced a functionality called a change set management, where ANSA DM efficiently tracks all the changes that are done on a part or subsystem level, which allows you to, in order to, when you're saving different versions of a particular subsystems, ANSA automatically tracks what changes that has been made by the user, and also allows you to store this information into a change set management tool that is available onto the drop down menu here. We have enhanced this functionality in version 22, where now it actually allows you to see what actions were performed by the user. So it gives an elaborative information regarding the action. For example, add part to the subsystem. So you have added an additional part, or you have changed and thickness of it. It gives in more information on what were the elements that were modified or the sets were modified and much more. So we have added two tabs called as action and entity. Another very important tab is the thumbnail. So this gives you a complete information about what has been changed on a subsystem level in a very graphical manner. So you can see here these are the three parts that were changed, and it allows you to track them much more efficiently. There are two more additional, let's say, functionalities that is available. Is the one more is the, let's say, on right click options, you can clear the change set that was been recorded, or you can also delete all the change sets in the model. So there are a few more functionalities that is available. One more important aspect of this change set management is user can now not only, let's say, looks at the change set that was done only from one version to another, but he can select the particular DM objects. For example, in this particular graphical manner that we are showcasing, that we have a subsystem one which was with the version 001, from which we derived 003. From 003 we derived 004 and another 005. So now if I wanted to compare or see the changes that were made between 005 and 001, you can actually select these two DM objects and right click on it and say show change set history, which basically allows you with a complete new GUI, which gives you a complete log of the change log, where it gives you in a very good summary manner that what changes that has been made from version 1 to version 5, and also gives you a complete thumbnail of what were the parts that has been changed. This is very important when you are creating multiple versions of your tool. Okay? And another version is the edit modifications, card modifications. So ANSA can now efficiently flag if there is any small change that was been made. For example, if you have a subsystem that has been stored and you have only went ahead and changed, let's say, for example, in this particular manner, that you have a set, but you went and changed a flag of the set as frozen delete yes, ANSA will efficiently track the changes that were made and also will show you these changes and into the change set management. Additionally, it will flag this system as a magenta color. That means it will show that there are changes that has been made for this particular one. So by this, I will pass it on to my colleague Sriram to
Thank you, Omkar, and thank you, Harish, for the introduction. I'd like to proceed with the following updates for the load case setup in respects to the topic of methodology enhancements that happened in version 22. Now, in version 22, FMVSS 201U load cases can now be set up in the modular environment with the aid of target point load cases. Now, this is the second tool that has been integrated in the modular environment after the pedestrian tool has been introduced last year. There are also have been some new developments for load case setup in the Nastran deck. Up to now, it was possible to control the load case setup per type, which boundary conditions of the model would be activated in all Nastran subcases through the load case header options. Going forward, we can also support the control on per type as well, which boundary conditions of the model would be activated in all the different Nastran subcases through the load case header options using the right click context menu options. It is also possible to activate specific boundary conditions of the model per Nastran subcase. This is supported through the boundary conditions, right click, add boundary condition sets per type in the load case header. Moreover, it is now possible to selectively echo interface nodes marked by interface points. This is achieved through the respective setting in the interface points, edit card functionality, wherein the user can activate on and off the echo functionality. And those specific nodes would be written in line as a keyword between echo on and off keywords in the solver file. Finally, some new features have been introduced in this version for the management of model variants. The relationship between multivariant and a single subsystem variant is now effectively tracked by ANSA. A lifecycle reference is created when a 100% variant is generated and saved in the DM, starting from the 150% variant of the model. Now, this can be seen in both the references tab of the DM browser and in the lifecycle references graph as well. Moving on, further enhancements have also been introduced related to the handling of part configurations. For example, if there is a use case wherein a model consists of several variant subsystems, for instance, we might have a body in white, which is a long wheelbase version, and a short wheelbase version, along with a roof, which has 4 different variants. Configurations can now be related to the subsystems using both multivariant and single variant subsystems. As a result, multiple configurations related to different subsystems can be activated simultaneously. Moving on to another topic, ANSA version 22 now offers new features to facilitate the collaboration between different users in the modular environment. In version 21, we have introduced a new functionality, which is called send to other DM functionality, which enabled the transfer of data from one central DM to a local DM so that the user would be able to work locally, make the changes. And once the changes have been made locally, you can push the data back to the central DM. In this version, this functionality has been further enhanced with the possibility to send the data back to a server-based SPDRM DM as well. With this improvement, the right-click send to SPDRM functionality has been added as a right-click context menu options in the DM browser. So this would allow the user to send new versions or new iterations of the model into a central SPDRM. Moving on, to facilitate the users working with cluster DM repositories, we have introduced a new key enhancements in the saving of the DM objects. If you're not aware, a cluster DM is a repository that consists of a main DM along with one or more library DMs. And when saving data into the cluster DM, ANSA can now identify that there are conflicts in when trying to overwrite the models in the cluster DM. So moving on, the override functionality would not be available when there are conflicts. Only a skip option and creating a new version of the model is available. Moreover, it is now possible to mark a file-based DM as a library DM in order to highlight that it is being used by the DM cluster. Now, this can be achieved through the dedicated setting in the DM structure XML file with an option set to yes. The added advantages would be it would prohibit the deletion of items in the cluster DM, and also a warning would be populated when trying to save the data into the cluster DM, where a warning is highlighted when you try to override the model. Moving on, in version 21 series, we have introduced a functionality that enabled the users to bypass a failed build action through the ignore option in the build action context menu, allowing the user to bypass this and save the subsystem into the DM, which was highlighted with a different color coding functionality. But this was not being tracked and saved in the DM repository. In version 22, we have added this option to save the build comment when a build action is ignored and saved into the DM repository. Right below the build status, you can see the build comment, which of the actions have been ignored. Moving on, the final area where new functionality is available is that of the effective configuration of the modular environment. Several enhancements have been introduced in the configuration of the build process definition. Firstly, a mixed order of build actions is now supported in the build tab of the modular environmental profile. Check templates and also the script actions can be inserted between or above the build actions. With a simple drag and drop functionality, the user would be able to modify it, and as well to make sure the setup of the custom build process more efficiently, copy and paste of the build actions is now supported between different build processes. So a subsystem which has a few build actions can be copied and pasted to a different connecting subsystem, for instance. to make the setup of the custom build process more efficient, we have introduced the double-click functionality on the scripts as well. So the user can be able to make changes if needed in the modeler environmental profile itself. A few additional options. The delete functionality of using the keyboard has also been introduced in the build process definition. Finally, the modular environmental profile effectively configures the model configuration in terms of the run architecture, the save and load options, as well as the build process of the model containers. However, the management of interface points, which is an integral step of the modular environment, was not managed through the modular environmental profile. From now on, the options of the modular environmental profile is controlled through the MAP, so that the user can save the settings related to the modular environmental profile inside the user specific profile itself. Finally, through the modular environment profile, it is now possible to separately control the file extensions of each model browser container. Now, this is achieved through a respective setting in the output options for the MEP. A new field has been added in the output parameters, allowing to define the user modular specific file extension. For instance, if you have a plain subsystem and that has a file extension .key, it is now possible for the very same subsystems to be included in a different simulation run, wherein the file extension for the simulation run would be a .kui file. That would conclude the presentation for today, and I would like to open the floor for any questions. Thank you.